Okay, so we're gonna cover hyperbolas today. So your homework tonight is 4.3e. Today we're gonna be graphing them and finding the different parts. So let's go ahead and find the definition of a hyperbola. And a hyperbola is the set of all points x, y in a plane, the difference of whose distance from two distinct points, called the foci, is a positive constant. So this sort of looks like two parabolas. We've got the happy parabola and the sad parabola in the same graph. So just like before with the parabola, it had a focus point. Now we'll have two focus points, one for each branch of our hyperbola. Now we'll also have the C and the backward C graphed together as well. What we're going to be graphing here are asymptotes, which we've already saw when we covered those rational functions. So let's go ahead and look at the parts of the hyperbola. So the graph of the hyperbola has two disconnected parts, which are called the branches. So over here, this is a branch, and this is a branch. The line through the two foci, it's going to intersect the hyperbola at 2 points called the vertices. The line segment connecting the vertices is called the transverse axis. And the midpoint of the transverse axis is the center of the hyperbola. So the center is going to be the midpoint between the two vertices, just like we saw with the ellipses. The first variable that you're going to see in the equation is going to be the axis that the graph is going to transverse. So this time, instead of our a squared and b squared moving, what we're going to do is we're going to move the x squared, y squared. And then the variable you see at the top is going to go ahead and the very first top left variable will be the axis that it transverses, whether it's horizontal or vertical. Let's go ahead and see the standard form. So this is when the center again is at 0, 0. The standard form of the equation depends on whether the hyperbola transverses the x-axis or the y-axis, or if it's horizontal or vertical. And a is always going to be first this time. So the a squared is always going to be the bottom denominator. Here, the x squared and the y squared are going to switch. Now, it sort of looks like the ellipse equation, but notice what's different is the operation in between. The ellipse had a plus sign. The hyperbola has a subtraction sign. And notice in my c squared equals a squared plus b squared here, notice this time it's a plus sign. So really what happened here is these two operation signs switched spots. When it was the ellipse, it was c squared equals a squared minus b squared. And the equation was the x squared plus, and then whether a squared and b squared were what moved. So this would have been an example of a possible ellipse equation. So again, here, the a squared is what's going to end up moving here, or the b squared. So the first letter that we see here, this will tell us whether our graph is horizontal or whether it's vertical. So if we see x squared first, then it's horizontal. If we see y squared first, then we know it's going to be vertical. Now, when we go to graph these, we're going to need to be graphing some asymptotes. And I want to see you graph the asymptotes. Again, remember the asymptotes are like the wall or the blocking point of our graph, how our graph is going to guide along it. So in this particular picture, our asymptotes are the blue dotted lines. And the equation, which we're going to see on the next slide, is our equation for the asymptote is going to be y is equal to plus or minus b over ax. Remember, this b over a, this is our slope. And notice there's actually two asymptotes that are graphed here. One is the positive slope, one is the negative slope. When our hyperbola is horizontal and the center is at 0, 0, our vertices, and they're on here in red, are located at the order pair plus and minus a comma 0. Our focus points are going to be the C value plus and minus C comma 0. However, when it's vertical, our vertices are going to be 0 plus or minus A. Again, vertical, the A is in the Y spot. Same thing for the focus. So the focus point, 0 comma plus or minus C. And then our asymptote is going to be Y equals, and we flip it, plus or minus A over B, X. And again, this is going to be the slope, our rise over our run. So let's go ahead and, again, they're officially showing us the asymptote equations on the next slide. So here are our equations for the asymptotes. So again, this is our horizontal hyperbola. So remember, it's the x squared over a squared minus y squared over b squared equals 1. And again, I'm just going to repeat what I wrote on the other slide. Your vertices are located when it's horizontal, meaning side to side, or transversing the x-axis, plus and minus a comma 0. And then your focus will be plus and minus c comma 0. Then when it's vertical, the equation is y squared, because we see y first, y squared over a squared minus x squared over b squared equals 1. Vertices, since my it's going to be vertical, my vertices are going to be 0 comma plus or minus a. The a is in the y spot. And for the two focus points, 0 comma plus or minus c. And again, your equations here for your asymptotes. So let's try an example. All right, so here is our first example. Remember, it needs to be set equal to 1. So I need to divide everything by 16. 4 over 16 is going to simplify to 1/4. So I'm just going to put x squared over 4 minus y squared over 16 equals 1. So the first variable I see, so what I'm seeing here is x squared. So the first variable tells me that if it's going to be horizontal or vertical. So it's going to be on or crossing the x-axis, because I see x squared first. And then notice there's nothing added or subtracted to my x squared, y squared. So this tells me my center is at 0, 0. So there's no h or k. So my center here is going to be 0, 0. So now I can see that this is going to be my a squared. This is my b squared. Remember, a squared and b squared don't move. This time the a squared is not the bigger number, it's the first number. So then a is equal to plus and minus 2, and b is equal to plus and minus 4. Remember, to get c squared is equal to a squared plus b squared. So let's fill it in. My a squared was 4, my b squared is 16, c squared equals 20. So then I have to square root it. So c is equal to plus and minus the square root of 20. Got to do that factor tree, 4 times 5. So c equals plus or minus 2 square root 5. Now, for graphing purposes, if you think about the two perfect squares that the square root of 20 is in between, it's in between 4 and 5. It looks like it's almost smack dab in the middle, so I'm going to say it's about 4.5. But again, we're graphing this on a graph that goes by 1. So just in the middle of 4 and 5 is what you're going to be looking for. So then this is approximately plus or minus 4.5 when we go to graph it. Now, when you go to list it though, you're going to list it in radical form. Now, remember, to get our vertices, when our center is at 0, 0, all we're going to do, and when the first variable I see is x, my vertices are going to be found by putting A in the x spot. So my two vertices are going to be -2, 0, and +2, 0. For my two focus points, or two foci, this one's going to be plus or minus c, 0. So you would list them as -2√5, 0, +2√5, 0. I also need to find my asymptotes. So again, for my asymptote, when it's going to be horizontal, remember you're going to be doing y equals plus or minus b over ax. This is when the x squared is first. So again, think of this as being y equals mx plus b, but in this case, our b is going to be 0, 0. So I'm going to plug in my b value, which is 4, and my a value, so it's plus minus. This will simplify to y equals plus or minus 2x. So in my y equals mx plus b form, this is my slope. Notice there's no b here. This would have been the plus b. So my b is 0. So my slope is going to be rise 2, run 1. These are going to be two linear equations. We're going to be graphing y equals 2x and y equals -2x. So a positive slope line and a negative slope line. So now we're going to graph it. And I'm going to tell you the steps that we're going to use to graph. So for graphing, what we're going to do first is we're going to graph the center. Then from the center, we're going to graph the asymptotes. And all you're going to do when you graph these asymptotes is you start at the center and then move the slope. So we just move the rise and the run from that center point. Then next we will graph the vertices. Then what we're going to do is we're going to graph it using the asymptotes as our guide. Then we can put in the foci. So let's go ahead and try it. So these are our 5 steps. So let's try it. So let me go ahead and put my graph here. First thing I'm going to do is graph that center point. And remember, the center was at 0, 0. Then my next step is to graph the asymptotes. Remember, my asymptotes were the equations y equals 2x and y equals -2x. So remember, all we're going to do is use the slope. So we're going to take this 2 and make it into a rise and a run. So 2 over 1. So I'm going to rise 2 and run 1. And it's sort of going to look like a box. So I'm going to do the positive one, up 2 and over 1. Down 2, I could go this way. For the negative slope, you could go up and left or down and right. So your two asymptotes, that's the negative asymptote, the y equals negative 2x. And then here's the y equals positive 2x. Next, we're going to graph the vertices. I had a vertice at negative 2 and comma 0 and positive 2 comma 0. So these are the vertices. This is the equation y equals negative 2x. This is y equals 2x. And the green thing is the center. And then now to graph it, I'm going to use the asymptotes as my guide. I just want to see that you take that point of the vertice and then skim your hyperbola along the asymptotes. And then we can also graph in our foci. And we said that's about 4.5. Let me extend it a little bit more. So my two foci, two in red, right here, right here. And that is your hyperbola graph. Your graph is going to be kind of fat or kind of wide when the smaller number, the smaller denominator, is going to be first. So in this case, it was 4 first. So once we simplified it, you see how this denominator here, the smaller of the two denominators is first. And when that happens, your graph is going to be kind of wide and fat. If the first number is the bigger number, then it'll be a skinnier graph. Again, set it equal to 1. So I'm going to divide all three pieces by 100. I'm going to simplify the fraction. So it'll simplify down to 1/4 here. So y squared over 4. This will be x squared over 25. And it equals 1. The variable I see first is the y squared. So this tells me it's going to be vertical. So my graph is going to look like this. The happy and the sad parabola, because I see y squared first. So again, a squared is always first. B squared is second. So a is equal to plus and minus 2. Oh, there should be a b. B is equal to plus and minus 5. And then to find c that we need for the focus, c squared equals a squared plus b squared. So c squared equals 4 plus 25. C squared equals 29. So c is equal to plus and minus the square root of 29. Now notice there is nothing being added or subtracted there with the x squared and the y squared. So this tells me my center is 0, 0. So that'll be my center point. And again, to approximate this focus, the two perfect squares that it's in between are going to be 5 and 6. So 25 and 36. So 5 and 6. It's closer to the 25. So less than 5.5. So maybe about 5.3 approximately. So again, when you graph it, it's a point between 5 and 6. So now let's go ahead and get our vertices. So again, the y squared is what we saw first. So when I go to write my ordered pairs for my vertices, my a value is going to go in the y spot. So my vertices are going to be 0, comma, plus or minus a. So 0, comma, negative 2, 0, comma, positive 2. For my foci, it's going to be 0, comma, plus or minus c. So this will be 0, comma, negative root 29, 0, comma, positive root 29. And for my asymptote, because my equation is vertical, it's going to be y equals plus or minus a over bx. So then let's fill it in. So plus or minus 2 over 5x. Again, my slope, I'm going to be rising 2 and running 5 from the center point. So let's go ahead and get all this information onto the graph. So my first thing I'm going to graph is the center. So my center is at 0, 0. Then from there, I'm going to graph my asymptotes. So I'm going to start at the center. I'm going to rise 2 and run 5. So if I go up 2 and over 5, and then if I go down this way, this is my first asymptote. And this is the equation y equals positive 2 over 5x. I can also go up and over to the left or down and to the right. Again, it's like a box that you're forming. So this is y equals negative 2 over 5x. Next, I'll get my vertices on here. So negative 0, negative 2, and 0, comma, positive 2. And again, use the asymptotes as your guide for your graph. So we'll just skim along going through that vertice. Skim along, going through the vertices. I'm not looking for additional points, just use the asymptote as the guide. So when you do this on the test, I will want to see the asymptotes graphed. And then lastly, we need to graph the focus points. So again, approximately 0, comma, negative 5.3, 0, comma, positive 5.3. Let me add some more marks here, 3, 4, 5, 6, 3, 4, 5, 6. So in between 5 and 6 doesn't have to be perfect. And again, those would be your focus. And again, the first number, notice that first denominator was a 4. Again, my graph is really wide. Now we're going to do it when the center is not at 0, 0. Okay, so here, now we have to bring back our h and our k. And our asymptotes also have to incorporate that hk. But again, when I go to graph the asymptotes, once you graph that center point, all you're going to do is move the slope from that center point. However, the equations down here of the asymptotes, if you think about it, this is just a modified form of point slope. So what they did was y minus y1, or your k. So this is point slope, and then m, x minus x1. But for our purposes, what we're doing here is y minus k, and then our asymptote here, it's going to be plus or minus, the slope will be b over a, and then x minus h. This is point slope. What they did was they took the k value here and they just added it to the other side. So that's why the k is over here away from the a. So what they did was they manipulated it. They took y minus k plus or minus b over a, x minus h. They just added k to the other side, and that's how they got y equals plus or minus, or they have the k first. They have k plus or minus b over a, x minus h. Again, recognize all of these. Also recognize it if they distribute the slope and put it into y equals mx plus b form. But honestly, all you have to do when you're graphing these asymptotes, you graph the center, and then we're just going to move this slope here from that center point. They did the same thing for the second asymptote when it's vertical. Remember, the slope is what changes here. It's the a over b when it's vertical. And again, they moved the k to the other side. So what it originally looked like was y minus k equals plus or minus a over b, x minus h. All they did was add the k, and then that's how they got what was in the box. What's important is that you memorize that when it's vertical, the slope is a over b. When it's horizontal, it's b over a. So let's go ahead and try an example of this. So here it is. It's already set equal to 1. So let me go ahead and pull out my center point first. So remember, the k is always with y, the h is always with x, and it's backwards on both. So my center here is the ordered pair, -3, -2. That is my center point. Remember, a squared is always first. B squared is second. And then c squared is a squared plus b squared. So a is going to be plus and minus 3. B is going to be plus and minus 2. So c squared is going to be 9 plus 4. C squared is 13. So c is plus and minus the square root of 13. And again, to approximate the square root of 13, it's in between the two perfect squares of 3 and 4, which is 9 and 16. And again, it's closer to 16, so probably a little bit more than half. So I would say about 3.6, but again, a point in between 3 and 4. So now, let's go ahead and find our vertices. So for our vertices, this time we don't have 0, 0, so we actually have to add the a value to that center. And because my variable I see first is y, I'm going to add a and subtract a to the k.
So the transverse axis would be the y-axis?
Yes. So here it's going to be h comma k plus or minus a. So it's going to be -3 and then -2 minus 3. And then the other one will be -3, -2 plus 3. So the two vertices are -3, -5, and -3, +1. My two foci, I use the c for the focus points, and I'm adding and subtracting it to the same variable. So it's going to be h comma k plus or minus c. And it's a radical, so I'm just going to leave it there. So it's going to be -3 and then -2 minus root 13, -3 comma -2 plus root 13. Now, for graphing purposes, remember what we did here is we said square root of 13 was approximately 3.6. So what we're going to do here for graphing purposes is -2 minus 3.6. So when I do this, I get -3 and -5.6. And then here, -2 plus 3.6. So this will give me -3 and +1.6. So for graphing purposes, this is the decimal. But again, when you're listing it, you're going to list it in radical form. So now that we have the center, the vertices, and the focus point, now we can also find our asymptote equation. So for the asymptotes, we're going to be filling in y minus k equals plus or minus a over b because it's vertical, and then x minus h. So k, again, it was negative, and then 3 over 2, and then negative here as well. So it becomes y plus 2 equals plus or minus 3 over 2, x plus 3. So if it asks you for the equation in point slope, this is it. Now, again, be able to recognize this, that if you subtract the 2, another altered form of this equation would be this, or if you distribute the 3 over 2, then this becomes y equals -2 plus or minus 3 over 2x. And then here, distribute it, and it becomes 9 over 2. Okay, so let's go ahead and get all of this information onto our graph. I'm gonna make my coordinate plane. So again, I'm gonna graph my center point first, and my center was -3, -2. So I'll do that one in green. That's the center. Then I'm gonna graph the asymptotes. Now again, you don't need to worry about these equations here that we formed. All you need to remember is from this center point, we're now going to move from -3, -2. We're gonna move the rise and the run. And remember, your slope was the 3/2. So we can go up 3 and to the right 2. So if I go ahead and rise 3, run 2, put a point here. I could also go down 3, 1, 2, 3, and then again to the right 2. I'm sorry, to the left 2. So 1, 2, 3, and then to the left 2. And again, here would be your positive asymptote. And then do the same thing going in the other direction for the negative slope. So again, rise 3, run 2. And again, it's like a box that you can form. So I could go down 3, 1, 2, 3, and then over here. And again, this would be your asymptotes. Next, I'm gonna graph my vertices. So I had one at -3, -5, right here, and then one at -3, +1. So right here, these are my vertices. And again, use your asymptotes as your guide. Skim along those asymptotes. And then again, also get in your two foci. So again, we approximated them to -3, -5.6. So probably right around here. And then -3, and then 1.6. So really close to those vertices. And that would be your two foci. So the focus points are in red. Your vertices were in blue. And then let me go ahead and outline the graph here in pink. So this would be the hyperbola. And again, it's transversing the y-axis because the first variable we saw was the y. Do one more example. So again, let me pull out my center. This is H, this is K. So my center point is the order pair +3, +2. When I go to graph it, I'll graph it in green. Then next, I can go ahead and see that it's going to transverse the x-axis because that's the first variable that I see. I could put a 1 underneath here. Remember, a squared is always first, then the b squared. So a is equal to plus and minus 1. B is equal to plus and minus 3. To get my c value, I'm going to go ahead and do a squared plus b squared. 1 plus 9, c squared equals 10. So c is equal to plus and minus the square root of 10. Again, to approximate its location, it's in between the two perfect squares of 3 and 4. It's closer to 3, so let's say it's about 3.2. So now for my vertices, the vertices are going to use the center point, the h and the k, and then that a value. Remember, the first variable we saw was x, so we're going to be adding a to the h, add and subtract it. So my two vertices are going to be located at 3 minus 1, comma 2, and 3 plus 1, comma 2. So 2, comma 2, 4, comma 2 are my two vertices. My two focus points, again, I'm going to take h and I'm going to add and subtract c and then the k. C was a radical, so I'm just going to fill it in. So it'll be 3 minus root 10, comma 2, and 3 plus root 10, comma 2. And again, remember the approximate value here, if I'm going to graph this, it'll be 3 minus 3.2. So when I go to do this, it'll be negative 0.2, comma 2 would be the approximate location of that one. And then 3 plus 3.2, comma 2, so 6.2, comma 2. So these are going to be the order pairs for graphing purposes for my foci. The next thing I need to do is find the asymptotes. So my asymptotes are going to be y minus k equals plus or minus b over a, and then x minus h. So again, my k value was 2. My b value is 3. My a value was 1. And then x minus 3. So my slope here now is plus and minus 3. Again, just be aware that you could distribute this, put this into slope-intercept form. You could also move the 2 over, which is your k, to get it set so that it looks like the notes. But again, all you need to do is graph the center, and then we're going to move the slope. And remember, your slope was originally 3 over 1. So we'll rise 3, run 1, and this is both positive and negative because we have 2 asymptotes. So let me go ahead and get those 2 asymptotes and the center point graphed first. So if I graphed my center point, which was 1, 2, 3, 1, 2, the order pair 3, comma 2. From that center point, I'm going to rise 3 and run 1. Go ahead and get some 1, 2, 3. So I'll go up 3 and over 1. I can also go down 3 and over 1. I can also go up and left. Then my asymptotes, and then go down. And again, it's like a box that's forming. But again, connect these. These are your asymptotes. Graph the vertices. So 2, 2, and 4, 2. Again, use the asymptotes as the guide. And again, throw in those 2 foci. And again, we approximated those to be about 6.2, 6.2 and comma 2. So again, right here. And then negative 0.2. So just on the other side. And we'll say really close. And those would be your 2 foci. And again, the blue are the vertices. And again, I can outline the actual hyperbola graph here in pink. And just make sure it goes through that vertice. And that are the examples of graphing the hyperbolas. Tomorrow we will work on writing the equations.